Welcome back, Algebra 2. We're in lesson 117. We're just going to learn some symbols today to illustrate and write our problems a little bit faster and not have to write out whole words. So for natural numbers, we know what those are. We write the capital N with this extra bar. For whole numbers, we write an italicized capital W. For integers, which we know what those are, we write this capital Z with the double bar in the middle. Rational numbers, which are anything that we can write as a fraction, terminating decimal, or repeating decimal, that's written as a capital Q with this extra bar here. An irrational number is written as a capital P in italics. We know what real numbers are. We've seen this symbol many, many times. We use it all the time. So it's the capital R with that extra bar on the left. And complex numbers, which is where we have the imaginary number, the I, that represents the square root of -1. We write that as a capital C with the bar on the interior left. So make a note of all of these in your notebook so you know what those numbers represent, or those symbols represent, whenever you see them in future problems. And we will be using them in future problems. If not this year, then next year. So normally we would have written something telling us to graph something where we would say x plus 2 is greater than 4 in the domain of integers, right? Well, now we're going to be using the set builder notation, which means we'll start with a bracket and we'll say x is a member of the set of integers such that x plus 2 is greater than 4. So now instead of having the real number symbol here, we'll be using whatever this domain is, we will write that here with our symbol. Okay, that will tell us what this is without us having to, have all the extra bad handwriting from Miss Tracy on the screen. Instead, you just get to see my little symbols and how I get to practice drawing those. But all you're doing is you're taking this part here, right, and writing it here instead. And you're taking this part here and you're putting the symbol that represents it right here. And then whatever the members are, you put them here. Member of the domain, and then these are the specifics. That's all it is. You do the bracket, you do whatever the members are, whether it's X or Y or X and Y, and then you do your membership symbol. And then you put the symbol for the domain. In this case, I just write the Z like this and then do an extra little doohickey in the middle, such that, and then your specifics, whatever the problem is, goes here. And then you close it with a bracket. Easy peasy. You guys can do this. All right, let's do a practice problem. That's all I have for 117, and it's right here. And I'm going to read this the way that it is supposed to be read. And I want you to try to follow along and see if you can see what I am going to say or what I'm saying, how it matches up with the symbolry, okay? I just made a word there, symbolry. Anyway, the symbols. So this is read as, graph the set whose members are ordered pairs of x and y, where x and y are real numbers such that y is greater than x plus 2 and y is less than -x. So did you follow along? Did you see how I read that through? The first bit is a little bit tricky because you say x and y more than one time. You say the set, that's kind of where you see the bracket, graph the set of whose members are ordered pairs where x and y are real numbers. Now, on this real number system or symbol right here, don't let this little square symbol, the 2 exponent, confuse you. Whenever we have the real number system, we're talking about a number line, right? Typically, when we talk about real numbers, we're talking about a number line here. That's evidenced typically by the x-axis in our coordinate plane. So all we're doing is we're adding another set of real numbers to create the coordinate plane. So we have an axis number 1 and an axis number 2. So 2 number lines is the coordinate system. And that's what this number 2 represents. It means that we have 2 number lines that we have to look at. That's all. It's not anything weird or mathematical that we have to worry about. It's something that we've already been doing. This is just what the official notation for it looks like. Okay? So let's look at these. Notice I've got, I don't know what I did right there. My little mark. I've got y is greater than x plus 2 and y is less than negative x. And these, neither one of them have an equal sign under them, so they're both dotted lines. So the first line, you see it crosses the positive 2 here. So this one has to be y is greater than x plus 2, because we identify that plus b part here. We also identify that this is a slope of 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. See? You recognize that bit? And now y is less than negative x has to be the other one. Y is less than negative x. And there is no plus b here, is there? So that means it's going to cross at the origin, the center. When you have no plus b, that's the same as saying plus 0, which the 0 on the y-axis is the origin. So you can always kind of visualize plus 0 right here when there isn't this, and know where that line is going to cross right here at the center. And this is a negative 1 over 1, right? A negative 1x. So it's down 1 over 1, down 1 over 1, down 1 over 1. We can see that slope. So these guys are perpendicular to one another because they're opposite and reciprocal, even though the reciprocal is still the same. So 1 over 1, 1 over 1, one's positive, one's negative. So that's what makes them perpendicular, is inverted, or I should say reciprocal and opposite signs. So now we want to graph this. Normally we would say graph the solution of this set of inequalities, and we would write y is greater than x plus 2. We would have our little bracket over here, and y is less than negative x, and then we would say in the domain of reals, that would be the whole thing. We'd have our instructions above. Now we just have to write this. So you can see how much easier it is and faster to just write it like that. Let me get my highlighter. So where would we graph? How would we solve this? So we need to find what is greater than x plus 2. We know that greater is going to be above the line. So above this line, right? Everything above this line on this side. But then it's going to be less than this line right here. So everything below this line. So the place where the two things overlap, above and below, is going to be right here. So it's below this line, but yet it's also above this other line. And that would be the way we would answer this problem. And that is all I have for lesson 117. I will see you in lesson 118.